Sobat 100, still with me Tricia in Seratus Institute program. In this time, we are going to talk about the Poisson distribution. Yes, still in this chapter. But today, we learn about using the normal distribution as an approximation for the Poisson distribution. The Poisson distribution with the parameter lambda may be approximated by the normal. Yes, with mean is lambda and variance is also lambda. If this lambda on Poisson distribution is greater than and equals to 15. Yes, if the lambda is too large, so you can approximate from Poisson to normal distribution. So you can say if x distribute by the Poisson with the parameter lambda, which is this lambda is too large, so you can say approximation. So you can approximate this distribution to the normal with the mean is mu and variance. Okay, remember about the Poisson distribution. Mean and variance on Poisson distribution are equals. So mu on this normal is lambda and also variance is lambda. Okay, it's clear? Okay, let's see the example. I have one example for you. The number of birds in a 1 year area, let's say x, can be modeled according to the Poisson distribution with a mean of 25. And what is the probability of 31 or more birds in 1 year? Assuming the mean has remained at 25. Okay, attention please. The Poisson distribution with the mean is 25, which is too large, right? Yes, because this lambda or mean is too large, you can approximate to the normal distribution with the parameters. The first one is mean, which is mu on normal is 25 and variance also is 25 because mean and variance are equals on Poisson distribution, which is 25. So you can write this approximation to the normal with mean is 25 and also variance 25. So the probability x greater than 31 can be write as a probability y greater than 30.5. Why? Okay, remember about the correction continuity. You have to apply correction continuity to limits. Remember about discrete data approximate to the continued data. You have to apply that correction continuity. And you just calculate with the normal distribution. It means you have to find out the z-score first. Remember about z-score? Yes. Z scores this number minus mu divided by standard deviation, which is root of variance. So you can write 30.5 minus 25 divided by square root of 25. You evaluate that, you get 1.1 for the z-score. But remember, this sign is greater than, so you can evaluate with 1 minus probability z-score less 1.1. Look at your table, look at your z-table for this number, for this value, and you get 0.8643 on z-table. You just evaluate 1 minus with this number and you get it 0.1357. So the probability x greater than and equals 31 equals to 0.1357. Okay guys, it's all done. So we have already talked about the Poisson distribution. Stay positive and happy. If you want to know more videos about the Poisson distribution, you can click the next video. See you.